All right, today we're going to dig deep, way, way deep into our planet's history to uncover its lost worlds. We're talking about giant supercontinents that existed long before our familiar map ever took shape. And trust me, it's a story that is going to completely change how you see our planet.
No, seriously, just take a second and try to picture it. If you could somehow pop back in time a billion years, you wouldn't have a clue where you were. The world wouldn't just be different, it would be fundamentally, utterly unrecognizable.
You'd find yourself standing on one single massive continent, surrounded by one single massive ocean. So you can forget about the 7 continents we all learned about in school. This was a whole different world, with one giant landmass, kind of like the famous Pangea you're looking at right here. It's an image that just rewrites our entire sense of home.
So what exactly makes a supercontinent a supercontinent? It's not just a cool name for a big piece of land. It's a specific geological concept. And, believe it or not, there's even some debate around it. Okay, so at its core, a supercontinent is what you get when most, or maybe even all, of Earth's continental plates cozy up and merge into one continuous block. Think of it like the planet's ultimate continental get-together. But, it's not always that simple. The geologist Paul Hoffman, for instance, has a really strict definition: a clustering of nearly all continents. Now, by that standard, Pangea makes the cut, no problem. But other huge landmasses like Gondwanaland? Maybe not. So you see, even the definition itself is part of this huge, ongoing scientific detective story. And this leads us to what I think is a pretty mind-blowing revelation. Pangea, the one supercontinent that everybody knows about, was really just the latest model off the assembly line. There was a long, long line of these planetary giants before it. So yeah, we've all heard of Pangea. But here's the big reveal. It wasn't the first, not by a long shot. The story of our planet's landmasses goes back billions of years, and Pangea had a whole bunch of ancestors.
I mean, just look at this timeline. It's absolutely insane. We start with a continent called which might have formed over 3 billion years ago. Then you get Kenorland, Columbia, Rodinia, Pannonia. Each one came together, dominated the planet for hundreds of millions of years, and then it broke apart. This isn't a fluke. It's a recurring theme in Earth's deep history. Of course, trying to see this far back in time is a huge scientific puzzle. We can map the last 200 million years, basically back to Pangea, with some pretty amazing accuracy. But before that, the trail gets cold, the clues are fainter, the picture gets a lot fuzzier. It's some serious geological detective work. So, how does this even happen? How do these colossal continents form and then just vanish? Well, it's all part of this grand planetary process. They call it the supercontinent cycle, and it's like an endless, slow-motion dance. And here's the most important thing to remember, the real kicker. Supercontinents are not built to last. The very process of them coming together actually plants the seeds for their own destruction. They are, quite literally, born to break. The cycle is this really elegant, continuous process. You have continents drifting together, smashing into each other, merging into one. And then, after a while, they start to rip apart and drift away again. This whole process sets the stage for the next big assembly. It's the slow, powerful heartbeat of our planet. And wow, this just lays it all out perfectly. On the left, you've got the supercontinent Pannonia from about 600 million years ago. Now, as it broke apart, those pieces drifted around, and eventually they came back together to form the next supercontinent in line, Pangea, on the right. The death of one world literally gives birth to the next. So this brings us to the part of the story that directly created the world we're all living on today, the Great Breakup of Pangea. This is the event that gave us our modern oceans in the 7 continents we know and love.
Now, the process was way more complicated than this, of course, but you can basically think of it as a 3-act play. Act 1, Pangea assembles. Act 2, about 200 million years ago, it starts to crack, splitting into 2 big chunks. And finally, Act 3, those chunks keep breaking apart and drifting, eventually moving into the positions we see on a map today. Those first 2 big pieces were Laurasia up north and Gondwanaland down south. Laurasia, that would eventually become North America, Europe, and Asia. And Gondwanaland, well, it split up to form pretty much everything else: South America, Africa, Antarctica, Australia, and even India. So every single continent today can trace its family tree back to one of these 2 ancient landmasses. And this all leads to one last really powerful thought. The continents are still moving, right now, as we speak. The cycle has not stopped. So in another couple 100 million years, they'll probably all come crashing together again to form a brand new supercontinent. The question isn't if it will happen, but what will it look like? And what kind of world will it be? Our planet's story, you see, is far from over.